Hey folks, Mrs. White here. This will be our first remote learning lesson that we're going to be covering. So luckily you folks, before school was shut down, we took our test on chapter 4. So we actually are starting something brand new. Today's lesson I don't think is too tricky, but I do know that transitioning over to remote learning can be pretty tricky. I know it's going to be really hard for me because I have a 2-year-old daughter at home. So I'm going to be recording these lessons either during her nap or after she goes to bed at night. Otherwise, it's going to be kind of hard for me to do it. So the plan is, moving forward, if you haven't read kind of the remote learning expectations document I asked you to do, that will have 2 video lessons a week, and each of those video lessons will have a homework assignment tied to it. If for some reason you're confused about something that's covered in the lesson, or you're not quite sure what to do with one of those homework problems, I am holding office hours in between each of the times we have classes. So those office hours obviously aren't real office hours. They're going to be times that I'm going to be on Zoom, and I'm going to open up kind of a conference call to everyone else. And I'll get those directions out to you folks. I'll post them on the classroom later. I know this is going to be tricky. If you have any questions, concerns, if something's not working for you, please, please, please reach out, okay? If you don't tell me, I don't know. So otherwise, these lessons, it's going to be kind of like having 2 flipped lessons a week and a homework assignment tied to each of them. So today, like I said, we're going to start out with chapter 5 since we had just finished a test. And today we're going to focus on operations with functions and focusing really on how do we add, subtract, how do we multiply, divide functions to each other. Okay, and we did this a little bit in chapter 4 when we plugged in. We did some composition of functions type stuff, and that's actually what we're going to focus a lot in our next lesson this week. But for today, we're just going to focus on adding, subtracting, multiplying, and dividing, and it's going to feel very, very similar to our polynomials chapter. So we are going to do a nice hefty word problem, which is going to be super duper fun. And then your homework is in the ebook. I do have a picture of it in the video, so if you're having problems accessing it, you can see it right at the end so we can discuss it. You're going to do 4 through 13 odd, which is not many problems, but I want to let you know this number 13 is a word problem. Since we're going over one, I thought that it would be beneficial and okay for you to give one a go yourself. So let's start off with our sit and begin. Let's look at factoring this polynomial, okay? Little review from stuff we might have seen on that test. So first things first, every time I'm asked to factor, the first thing I should be thinking about is GCF, okay? So I'm going to look here. This has an x to the 4th. This has a y to the 6th. Since they're different variables, I can't divide anything out of it. However, my coefficients on both of them are divisible by something. They're both divisible by 12. So I can greatest common factor out of 12. So I'm going to have a 12 on the outside. 48 divided by 12 is going to give me a 4, x to the 4th, minus 12 over 12 is 1, so I'm going to be left with a y to the 6th. Now at this point, if your exponents were 1, you would be done because you can't simplify it any further. However, noticing that this is 2 pieces, and that it is a subtraction problem, I'm saying to myself, this is either, or potentially either, a difference of squares or a difference of cubes. And you might be saying to yourself, Mrs. White, I don't remember how to figure that out. Well, I'm going to look at both of my exponents. And I'm going to ask myself, if it's a difference of squares, then are those exponents divisible by 2? If it's a difference of cubes, are those exponents divisible by 3, meaning that I could cube root each piece? Well, kind of previewing ahead, it looks to me like both of these could be divisible by a 2, so it's probably a difference of cubes. A difference of squares. So that means I'm going to pull a squared out of this. I'm going to ask myself, what times itself equals 4x to the 4th? Well, what times itself equals 4? That's easy. It's 2. And what times itself equals x to the 4th power? Well, that's going to be an x squared. Over here, I can ask myself, okay, what times itself is y to the 6th? Well, y to the 3rd times y to the 3rd would mean I would add my 2 powers. That's going to give me y to the 6th. Now, another way to double check this, folks, is using our exponent properties. When we have a power to a power, you multiply. So 2 times 2 is 4, and then I would have 2 squared, which is 4, so 4x to the 4th works. 3 times 2 is 6, y to the 6th, oh, it matches up, it works. This is a difference of 2 squares. So now is where you just kind of have to have the difference of 2 squares memorized, okay? We're going to treat our first little parentheses piece here like A. our second piece like b. And our shortcut is that we're going to do a plus b, and then we're going to do a minus b. Now, in a difference of squares, that's how we go about solving it. So I'm going to stick my 12 on the outside. I'm going to do a plus b. Instead of a, I'm going to put 2x squared. Plus, instead of b, I'm going to put y to the third. Then I have to do the second part, which is just a difference between the two. So a minus b, so 2x squared, minus, instead of b, I'm going to put in y to the third. Now at this point, I should look here and ask myself, is this anything special? Because both of these exponents are higher than 1. So if it's a sum of two pieces, it could potentially be a sum of cubes. But this is not a cube divisible by 3, and this is not a perfect cube, so I can't do anything there. This could be a difference. It could be a difference of squares or a difference of cubes. I'm going to look at my powers. They're both not divisible by 2 or 3. Okay, this one's divisible by 3, this is divisible by 2, but neither of them have it both in common, right? I can't divide this by 2 and this by 2, or this by 3 and this by 3. That means this is my polynomial in factored form. Okay, it ends up having 3 pieces. Don't forget the 12 from when you GCF'd it in the very beginning. So there's a nice little refresher of an item that was covered on the test from before we were shut on down. Okay, let's start talking about some new stuff. So if you didn't pull out a notebook right now, you definitely want to. We're going to look at operations of functions. And again, operations is going to cover addition, subtraction, multiplication, and division. And we've already done pretty much all of these. Okay, we've done all of these things in our polynomial chapter. So let's look at how we could write these in our actual definitions, keeping everything in terms of f of x, okay? So if we're dealing with functions, we're dealing with function notation. So when we see this here, it's saying f plus g of x, f plus g of x. So the real directions for this is take our f of x, take our g of x, and add the two together. So let's say f of x equals 2x and g of x equals negative x plus 5. If we were to do f plus g of x, we're going to take our f of x function, which is 2x, and we're going to add to it, in parentheses, our g of x function. And g of x right here, boom, negative x plus 5. Now to add those, all I have to do is combine like terms, okay? So I have 2x, I'm adding to it a negative x, that's going to give me 1x, and then here I'm adding a positive 5, so it's really just going to be 2x minus 1x, which is x, and then I have no other constants, so I keep my plus 5. So if I were to write this out in function notation, I would put, and I'll put it kind of to the side here, f plus g of x equals x plus 5. Okay, remember, it's important that with function notation, we list the work we did, okay? It's telling the reader what we plugged in and what we got out. So when I do f plus g of x, I get x plus 5. All right, directions in, resulting output. Well, I'm sure from here you can probably start figuring out the rest of this, right? If we have f minus g of x, and that's how we would read it, f minus g of x, we're going to take our f of x function and we're going to subtract from it g of x. So really, it's just like what we've done with polynomials. Let's just put an equal sign and we'll start writing our work here. So I'm going to start with my f of x, which is 2x. I'm going to subtract from it g of x, but because g of x is a binomial, two pieces, I'm going to stick them both in parentheses. Now think back to our last chapter. Whenever we are going to subtract a polynomial, we need to make sure to take this negative and distribute it across. And we didn't talk about that here because we don't need to distribute a positive. So if I distribute that negative across, I'm going to end up with negative times a negative is a positive, so I'll have 2x plus x, and then negative times a positive is a negative, minus 5. Well, 2x plus x is 3x, and I'm going to keep it as 3x minus 5, all right, after I combine like terms. In order to have this correct, I need to make sure to put my label, f minus g of x equals, and then my actual solution, right? We need to make sure we put our input and our output. Next, hopefully right now you're like, oh my gosh, today's lesson, and this is going to be our lesson today. Okay, today's lesson is the bomb because it's really not that bad. Again, it's a nice review of all of the computation that we did. It's just using function notation. So, multiplication, f times g of x, which is how we would read this, f times g of x is like f of x times g of x. So I'm going to take my f of x, which is 2x, and I'm going to multiply it by, and I'm not going to put the multiply symbol, right? I'm just going to put parentheses over here, negative x plus 5, because that's my g of x. This is a mono and a binomial, so I'm going to take this one chunk and I'm going to distribute it across. If this was a binomial times another binomial, I would have to double distribute, and some of you might call that foiling, depending on who you had for Algebra 1, okay? So distribute or double distribute or triple distribute, remember, that's just how we multiply polynomials. So 2 times negative 1, my coefficient here is going to be negative 2. X times x is x squared. 2x times positive 5, 2 times 5 is positive 10. And I'm just going to bring my x over. Now this is my answer, but again, I need to make sure I put my function notation with it. So I should say f times g of x equals, and then that specific answer. Okay? Now, just so you folks know, I'm looking at getting my hands on an iPad. Right now, I'm trying to do this with one of Mrs. Mountcastle's drawing tablets, and it's pretty tricky to do the writing. So if it seems like, you know, I'm kind of struggling with my penmanship today, I am. It's because I'm writing on a separate tablet that's then projecting it on the screen. So I'm sorry if it's a little tricky. Let's look at our last thing we're going to cover. F divided by g of x equals f of x divided by g of x. Okay. Which again, this is just a notation piece. This is going to be f divided by g, okay? Now here they did put this little piece. They're saying that g of x cannot equal 0. And you might be like, well, why would you need to write that? Well, let's take a look. If we're dividing by something, that means that something would be in the denominator, and our denominator can never equal 0, okay? If you think about it, when you divide by something, that's how many pieces you need, right? If I have 5 and I'm dividing it by 5, how many is going to be in each of those 5 pieces? It's going to be 1. If I had a denominator of 0 and a numerator of 5, I would be saying take my 5 and divide it into 0 pieces, which doesn't make sense, right? Because if I have 5, I'm going to have at least one group of 5, right? So I have to have at least a 1. That's why they put cannot equal 0, because your denominator can never equal 0. So now let's set this one up. F of x is going to be 2x. Over negative x plus 5. Now, you might say to yourself, Mrs. White, what do we do now? Should I set this up as long division where I have 2x divided by negative x plus 5? I mean, we can take a look and see what we could maybe do, okay? I would want this to look like this. So how can I make negative x look like positive 2x? Well, I could times it by a negative 2. And then distribute my negative 2 in and in. I don't have a constant here, so I should put a 0, plus 0. So negative 2 times negative 1 is positive 2. And then it's going to be an x. Negative 2 times positive 5 is negative 10. I change both of my signs. And then this is weird. Look, I end up with a negative 2, okay? I end up with a plus 10 here, so plus 10 over my divisor, negative x plus 5. Now, this did not turn into anything nice, right? I end up with just a constant and then some weird remainder. And usually we would be happy with this, but because there's no x in it, folks, because when we divided these actually had the same powers and it was a mono over a poly versus the other way around, I cannot do anything here. So I'm actually going to have this be my actual answer. I can't technically simplify it any further without getting some gnarly remainder. So I'm going to rewrite it. F divided by g of x equals, and then 2x over negative x plus 5. Can't do anything else. Boom, shakalaka. So really, the only new thing here, we know how to add polynomials and subtract them. We know how to multiply and we know how to divide, okay? The big new piece here is, what does this notation mean? And I think it's pretty easy to recognize, right? This is a parent function, this is a parent function, we're plugging in x. This is a parent function, this is a parent function, we're plugging in x, and so on and so forth, okay? And it's telling us what math to do. So what I want you to do is take a second, okay? At these 4 examples, if you want to pause the video, give each of these a go, okay? And then press play, and I'm going to go over each of them. So let's start off. If you haven't pressed pause, press it now because I'm going to start going over them. Let's start by going over this problem. It says f plus g of x, so I'm going to be adding my f and my g together. They both already have x's plugged in. So I'm going to start out with my first one, which is x squared plus 5x minus 2, and I'm going to add to it, and I really should have both these in parentheses, right, because they're more than a mono, 3x minus 2. When I add polynomials, I just combine like terms. I have no other x squared, so I'm going to keep that. I have a positive 5 and a positive 3, so I have positive 8 x's, and negative 2 and negative 2 is constant, same sign add and keep, negative 4. So my answer is f plus g of x equals x squared plus 8x minus 4. Pretty straightforward. Let's go over to our next one. I notice this says f minus g of x, so I'm really going to do f of x minus g of x. So f of x, again, is this trinomial. X squared plus 5x minus 2 minus this binomial here for g of x, 3x minus 2. Now, when we subtract polynomials, again, very important to remember, we distribute the negative across to both pieces, okay? Distribute that negative right across. So I really end up with negative 3x plus 2. And now I'm going to combine like terms. So there's still no x squareds. So I'm going to have my f minus g of x is going to equal x squared. I have 5 x's. I'm subtracting 3, so I have positive 2 x's. And then I have a negative 2 I'm going to add to. That would be a plus 0 here, but I never really have to write plus 0. So my answer is x squared plus 2x. Let's go down to looking at multiplication and division, okay? We have some different parent functions here. We have f of x equaling still a trinomial and g of x equaling a binomial, but they're a little different. This is telling me to multiply, so I'm going to take my first one, x squared minus 7x plus 2, and I'm going to multiply it by this binomial here for g of x, x plus 4. So you could, remember with multiplication, if we have 5 times 3 or 3 times 5, we're still going to get 15. So it doesn't matter if you distribute the x squared in, and then the 7x in, and then the 2 in, or if you decide to do x to all 3, and then the 4 to all 3. Either way, you're going to end up with 6 different products. So let's start. I'm going to just send this to everything here first. So 1, 2, 3. Sorry about that. So x to the first times x squared, x to the third, minus 7x squared. And then plus 2 times x is going to be plus 2x. Then I'm going to take my 4, and I'm going to send that across also. I'm going to send it here and here and here. So 4 times x squared is positive 4x squared. 4 times negative 7 is going to be negative 28x. And 4 times 2 is going to be positive 8. My last step is to combine like terms. So my highest power here is x to the third. Then I have a negative 7x squared and a positive 4x squared, which gives me negative 3x squareds together. Then I have a 2x and a negative 28x, which gives me negative 26x, and then a plus 8. Now again, I should put my label of what work I did. F times g of x equals, and then this answer right here. Okay. Last example we're going to cover right now is f divided by g of x. So I'm going to take my f function, I'm going to take my g function, I'm going to set it up as a division problem. So we'll start off with my f. X squared minus 7x plus 2 over x plus 4. Now hopefully looking at this you would say it's a poly over a poly. If it's a poly over a poly, we could divide them potentially, okay? You want to look at this power and this power. If this power is larger, then I potentially can divide this out of it, okay? So that's what I'm going to check for. I'm going to either do, let's see, in the SITMAGIN we reviewed log division. Let's review synthetic division, okay? So if I'm taking this and dividing this out of it, my number in the box would be negative 4. It goes 2, 1, and none, so I don't need any fillers. My coefficients are 1, negative 7, and positive 2. My remainder is going to be here. I'm going to drop my 1. 1 times negative 4 is negative 4. Negative 7 and negative 4 together is negative 11. Negative 11 times negative 4 is positive 44. And 2 and 44 is 46. So we could write this, okay, as, let's see, we would do, this is a squared, so we decrease the power by 1. It would be 1x, or just x, minus 11 plus 46 over our divisor, which is x plus 4. Now, this is the answer to that division problem, but did this divide nicely? Hopefully your answer is no, right? X plus 4 is not a factor because our remainder would have to be 0, and this is not 0. So really, if you can't simplify it nicely, as in you do the division and there's a remainder, you really can just leave it just like this, but make sure that you don't actually leave it just like that, right? You want it to have the label in front. Okay, so let me repeat that one more time. If you go to do the division and you end up with a remainder, it does not divide nicely. That means this is not a factor. You're going to leave it, okay, for this specific unit right now as the original division problem. Let's take a look at one word problem, and then I'm going to let you guys start practicing on your own, okay, because this stuff is very familiar and very similar to stuff we've done in the past. So let's take a look here. A robotics competition team is preparing for a tournament. The team's captain is ordering custom t-shirts for each of the members. The t-shirts cost $8 each, plus a one-time setup fee, and sales tax on the order is 8%. The team decides that the members will split the cost of the t-shirts equally, and that the team's captain and vice captain will not have to pay for theirs. So we're asked to do a few things here. First off, they're asking us to write a function, c of x, that is going to represent the total cost of the t-shirts, where x is the number of team members. Okay, so every team member in it. So let's start by thinking about maybe tax. Okay, normally this would be the last thing I would think about, but I know you folks are probably not excited to have to figure out 8%. If you're figuring out 8% of anything, you would change your percent to a decimal by moving it forward 2 places and multiplying it. Now, we don't want to figure out just the sales tax. We want to get the total order, right? The sales tax and the actual total. Well, instead of saying that we'd find 8% and then add it, we could just say that we're going to take the whole thing and we're going to times it by 1 to get our, kind of our total before tax. And then we're going to times it by the 0.08. So when we multiply something by 1.08, that's going to calculate the cost and the 8% tax. And then over here is where we'll put the rest of the equation for now. So now that we've got that taken care of, we're going to do 8 per shirt. The word per implies multiplication. We're going to have to buy the same amount of shirts as there are team members. And then we have to pay for, so we're going to have to add to it a $25 cost. Now, instead of leaving it like this, okay, because as we move forward and look at the rest of the equations, we're going to be using tax again. I don't want you to get confused about it. I do want to distribute it right across here, okay? That way we have a simplified function that we can work with. So our cost function for our amount of players is going to be 1.08 times 8. So grab out your calculator. 1.08 times 8 is going to give me 8.64 x. And then 1.08 times 25, so 1.08 times 25, it works out nicely. It's plus 27. So this is the function that's going to represent the total cost, okay? Total cost, that's why we're using a c. In the next question, they say write a function to represent the number of team members who pay for the t-shirts. So they didn't tell us that x is going to be anything different. So we can assume that x is still the number of team members. But remember, up from our problem, not everyone is going to be paying for a shirt, right? The captain and the vice captain are not. So we have all of our team members, okay? Those who are going to be paying for the shirts are going to be x minus 2, right? Not plus 2. There's not 2 extra people. There's 2 less people, so each of these are going to have to pay a little bit more, okay? And there's nothing to simplify here, so I'm ready to go on to my next piece. Find c divided by n of x and explain what this function represents. So I'm going to do c of x, which is this, 8.64x plus 27. And I'm going to divide it by x minus 2. Now, we did talk about in our last problem, right? If they have a higher power here and a lower power here, you could try to divide them and see if it divides nicely. However, this does not seem to be able to do that because these powers are the exact same. Okay, so I'm going to leave it simplified like this. And what this means, folks, is that this would actually represent the total cost divided by the amount of people, right? That's what C is, total cost. This is the number of people paying. So this is the cost divided by number of people, or the cost per person, okay? That's what this will represent, the cost per person. And again, I figured that out because this represents total cost. This is division. This is the number of people, cost per person. Okay? So now we're going to actually use this division problem to figure out how much each person has to pay. So if there are 15 team members, how much does each paying team member contribute to the cost of the shirts? I'm going to plug in 15 for X. So I'm saying use X equals 15. Or find C of 15 and 5n of 15 and plug them both into this problem. Either way, I'm essentially doing this. Oops. Okay. So my denominator, I'm going to start with first, 15 minus 2. Well, that's super nice. It's 13. 8.64 times 15. I'm going to need my calculator for that. I'm going to get that, and then I'm going to press plus 27. And then I'm going to divide that plus 27 by 13. And I'm going to get 12.05. And I want to make sure if I had to round that I'm running to the nearest penny. So each person has to pay $12.05 to pay for their shirt and the cost of the two other shirts for the president and the vice president. So we wrote a function for cost. We wrote a function for the amount of people. We did some division, or we set it up as a division problem and then plugged in a number to actually find a solution. Okay? So tonight's homework, not due until midnight before our next video lesson, so check out the calendar, is to do these problems. So 5, 7, 9, and 11. This is actually a lot of work, okay? You need to add, subtract, multiply, and divide for each of these. So 5 should have 4 answers: addition, subtraction, multiplication, division. 7 should have 4 answers: addition, subtraction, multiplication, division. This should have 4 and this should have 4. So right here, you're actually kind of doing 20 problems. Then, I just want you to be really good at it, okay? I want to be able to move on, easy peasy. Then I want you to give a go to this word problem. Again, I do have office hours. I'm pretty sure for you folks it's going to be on Wednesday. I haven't determined the time yet because I'm going to be looking at the comments that I left on our class pages. So all the Algebra 2 honors pages. I'm going to see what's most convenient for folks, and that's when I'll be available. I'll make sure to post it. So give a go to this problem, okay? Give a go to all those, and we can discuss them during office hours. Otherwise, you need to hand them in by midnight on Wednesday. Thank you, folks. I will get back to you at the very latest on Thursday. Hopefully, you can stop by and hang out during office hours and check in. Thanks. Bye.